Okay, lesson 2 for unit 3. We have types of decay, positron and positron emission, electron capture, decay rates, and half-lives. All right. I want to do a quick recap of the types of decay. Types. Remember you have alpha, which is similar to a hydrogen, or not hydrogen, I don't know what I was thinking, helium atom. So here's an example of a nuclear equation. You will see this on your worksheet. Here's an example. You guys will be able to refer to the periodic tables in your book or the big one behind me. All right. I don't expect you guys to have all these elements memorized yet. I don't even have all 118 memorized. I have most of them memorized. What element is PO? What is it? It's no, that plutonium is just a P. It's a PU, actually. Yeah. This is polonium. This is something that Marie Curie discovered. I'm going to have polonium go through alpha decay. Now remember, the left side and the right side must equal each other. So if on the left side I have 210, on the right side I have 4 for a mass number, what must the other number be to add up to 210? 4 plus what would equal 210? So this number is going to be 206. On the left side, you have 84. And again, you guys are getting this on Monday, so pay attention. On the left side, you have 84. On the right side, you have 2. 2 plus what equals 84? 82. What element has an atomic number of 82? Lead. There's your mystery element. This is a nuclear equation. These are things that you'll be doing on Monday's assignment. This is a nuclear equation with alpha particles. Next, we have beta, which is the same thing as an electron. Remember that an electron has a -1 charge. So let's say I have carbon 14. I have an electron here. You must remember that an electron has a -1 charge. It practically has no mass. So what would, if this side over here is 14 and this electron basically means 0, what will the other mass number be for our mystery element? Remember, the electron is basically 0. So if the left side is 14 and this electron is 0, what is this mystery element's or this mystery isotope's mass number? You're not getting me. This is 14. This is 0. There's really no mass there. So if the left side is 14, what must the right side be? This mystery thing that I don't have written down yet, if the electron is 0. 14. Now the charge of an electron is -1. On the left side, we have 6. This electron means -1. What must this number be that I'm missing right there, where -1 plus x equals 6? 6 plus -1 equals 6? 5 plus -1 equals 6? Nope. What is it? 7. You're going to need some practice. That's what money's going to be all about. What element has an atomic number of 7? Nitrogen. You refer to the atomic number to identify it. This is another nuclear equation. And then gamma rays are the third type, but you really can't do any nuclear equation with that because they're massless and they're chargeless. Okay, so let's go to something new for you. Positron emission and electron capture. Positron emission is exactly what it sounds like. A positron is emitted from the nucleus. And this is the vocab word of yours that you'll be getting. A positron is basically, guys, it's like a positively charged electron. Its symbol is either that of an electron but with a positive sign, or a beta particle with a positive sign. Because it is the size of an electron, it really doesn't have any mass. So it's just a positive one charge. That's it. During positron emission, a proton is converted to a blank and a blank. What is inside of an atom that has the same mass as a proton but no charge? Yes. And then what basically has no mass but has a positive one charge? And we are doing it right now. A positron. So I want you to understand something. This is a neutron. No charge. 1 AMU. That's mass. This is a positron. No mass. A positive one charge. If you were to combine a neutron and a positron, what would you get? Something that has 1 AMU for mass and a positive one charge. What is that? A proton. And the reverse is true. If you take a proton and you divide it, you'll get something with no mass but a positive one charge, and then something with no charge but 1 AMU for mass. That would be a neutron and a positron. So a proton results in a neutron plus a positron. So I want to do an example for you. It's something that you might see on your work. Okay, Varun, this is what you were talking about. Now, you guys might need your calculators. You might not. Let's see what you can do. That is carbon 11. What is this carbon's atomic number? Look at the numbers you have. Can you tell me which one of those is the atomic number? 6. And what does the atomic number represent? So this has 6 protons. How do you determine the number of neutrons? What is 11 minus 6? 5 neutrons. Is this a 1-to-1 ratio? No. So you need to fix that. So what I want to do is I want to add a positron. Or excuse me, I want to emit a positron is what I meant to say. If you emit a positron, you're releasing 1 positive charge. What will that atomic number change to? The atomic number, you need to know, guys, this is basic chem. That 11 is the mass number. It is the protons plus neutrons. This number is the atomic number. This is the number of protons. If I take out a positron, I'm taking out a +1 charge. So which number will change, the mass number or the atomic number? If I'm taking one +1 charge away, what will the 6 turn into? Becomes a 5. Does the 11 change? No. What element or what number do you now use to identify the new element? Do you use the mass number or do you use the atomic number? I got one student out of 31 telling me this stuff, and that tells me that 1 out of 31 knows it. Which of these two numbers do you use to actually determine what the identity of the element is? Do you look at the 11 or do you look at the 5? You look at the 5. What element behind me is element number 5? Boron. That's your new element. And now check out the ratio of protons to neutrons. You got 5 protons and 6 neutrons. That's a little bit better. If you had to choose, you would want more neutrons than protons than the other way around. This is an example of positron emission. Okay, next is going to be electron capture. What is the charge of an electron? -1. So let's just, don't write this down. Just watch. If I have 81 and I add an electron, what is my new charge number? 80. Good. What if I have 81 and I remove the electron? What is my new charge number? I took the electron out. 82. So you got to know when you're taking electrons, and then you got to know when you're releasing them. Whenever electrons are on the right side of this yields arrow, you got rid of it. Whenever electrons are on the other side of the arrow, you're adding it. So in electron capture, you decrease the number of protons in an unstable nuclei. So let's do an example. I have rubidium 81. And I'm going to add an electron. What number will change? The mass number or the atomic number? The atomic number. So I have 37. I'm adding an electron. The charge of an electron is -1. What will that do to the 37? Make it 36, Kellen. Does it change the mass number? No. So Kellen, you have a periodic table right in front of you. Can you tell me what is our new element that has a mass number of 36? Krypton. This lowers your proton number because you had an unstable nucleus. You're trying to stabilize it. This is going to be called Krypton 81. And this is known as electron capture. Okay, we have about 4 minutes left. I'm barely going to get in radioactive decay for you, and you're going to need your calculator for this one. There's a method of dating things that are very old. It's called radioactive decay rates in dating. Decay is measured in half-lives. A half-life is the time, vocab word, required for 1/2 of a radioisotope, a radioisotope's nucleus, to decay. Example is strontium 90. Its half-life is 29 years. So I want to give you an example. It is the year, let's make it very easy. In the year 2000, I have 10 grams of strontium. What is strontium's number or symbol? Let's say strontium. Crap. I have 10 grams of strontium 29. Flash forward to the year 2029. How many grams do I have? Well, what's half of 10 grams? 5. A half-life is the amount of time it takes for half of what you've got to decay. Let's say that you have a half-life of 5 years. You weigh 200 pounds today. How much will you weigh in 5 years? 100 pounds. It's that simple. So if I had 10 grams of strontium 90 today, I would have 5 grams of it in 29 years. The equation for half-lives is N equals N naught times 1/2 over little n. What's another number you could put in your calculator besides 1/2? I would do 0.5 if I were you. Hey, so calculator time. Okay, listen up, guys. I have 10 grams of strontium. Darn. Here's what I'm going to do. I'm going to take back the assignment that I was expecting you guys to do on Tuesday because honestly, you're not ready for it. And I'm not going to make you do something that I don't think you're ready for. So I'm going to get you something else. We will continue this talk on Wednesday. You're not ready for